Good morning, everybody. It's Mr. Rowan here. Um, we are going to be learning about trigonometry today. Um, Go ahead and try the warm-up questions on your own. We're not going to worry about those, but we might try them in class. So today we're going to start learning about trigonometry, which is something that maybe you've heard about, maybe you're a little bit scared of. But it's pretty easy. So trigonometry, it's basically just learning all about right angles, mostly, and right triangles. That's what I mean. So basically, we're going to talk today about how the sides and the angles of certain right triangles are related to each other. So I'm going to start off with a vocab term, the reference angle. We see it represented by a theta, this little symbol down here. That's the Greek letter theta. So then we know that the hypotenuse is the longest side. And then when I talk about the opposite side, that's going to be the side that doesn't touch the reference angle. Okay, so there's always going to be in every right triangle, there's going to be three sides depending on what reference angle you use. So there's going to be an opposite, hypotenuse, and an adjacent. So adjacent just means next to. So in this case, let's take a look here. The hypotenuse is going to be the little lowercase c, also known as side AB. And then the side opposite to that, that's just the lowercase a. And then the adjacent is going to be the lowercase b. So if you want to label them as BC, AC, AB, that's fine too. Okay, so there are three basic, what we call trigonometric functions. And so there's a sine, cosine, and tangent. You won't see them written out very often. Most of the time, you're just going to see sin, cos, and tan. You'll see them as their abbreviations. So when we talk about each one, yeah, let's just go ahead and make sure that we write our abbreviations first so you know kind of what they look like. So sine, cosine, and tangent. And we say it as sine of theta, cosine of theta, tangent of theta. And this refers to a specific ratio here. So the sine of theta is going to be the ratio of the opposite side divided by the hypotenuse, or a over b, or sorry, a over c, if we're looking at that triangle. And remember, this is only the sides, so you're never going to be dividing the angles in this case. Sort of like last time with the similar triangles, you always used the side lengths as your ratios. So with cosine, it's adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. Cool. Which in this case is a over b. All right. This is super important. You'll have to memorize all of these. But there's a pretty easy mnemonic that we use in the field, which is SOHCAHTOA. Sounds like a volcano, or like some Hawaiian god. SOHCAHTOA. Or like a karate word. SOHCAHTOA. Anyway, so sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and toa, tangent, is opposite over adjacent. So just remember SOHCAHTOA and you should be fine. So we're going to do a couple of examples so that you can see this a little bit more clearly. Gonna write SOHCAHTOA at the top of the page so that we remember what we're doing. All right. So we're going to start off by naming our sides, and if you would like, you may pause the video and see if you can do this on your own, or you can just follow along, whatever feels comfortable for you. So the hypotenuse of QRP in this case is going to be the long side, the one opposite to the right angle. So that is 17. So it's QR or RQ. And the leg opposite to Q is going to be 8. So that means, of course, that the leg opposite to R is going to be 15. So the leg adjacent to Q is going to be the one that's opposite to R, and the leg that's adjacent to R is going to be the one that's opposite to Q. So notice how we have 15 and 15, and then 8 and 8. Okay? The leg adjacent to R. Oops. Leg adjacent to R is 8. Okay. So we're going to go on and look at how we find the following trig ratios. So we're going to start by circling the reference angle, and then from that reference angle we'll label the other sides. Now the hypotenuse is going to stay the same. The hypotenuse is always going to be that 17. It's always going to be RQ. But which side we use as opposite and which one we use as adjacent depends on which angle is our reference angle. So if we use Q, then it's going to be 8 over 15. 8 over 15. Okay. Or sorry, 8 over 17. Delete, because it's opposite over hypotenuse. Now if we do the cosine, then it's going to be 15 over 17. And so then the tangent, opposite over adjacent, that's the one that's 8 over 15. 8 over 15. Yeah. So yes. Okay. Now you're going to see some similarities here when we do the same situation for R. And I'll let you go through and test those out on your own.